Hey guys, so last thing we're going to learn this week will be factoring special cases. You might remember me telling you about the difference of two squares. So this would be the difference of two squares. The same thing in parentheses, one's positive, one's negative. So to show you how it ends up panning out, I'm going to go ahead, I set up a box and I'm going to multiply. I'm going to get x squared when I multiply x times x, and I'm going to get negative 4x when I multiply the x and the negative 4. Right over here, I'm going to multiply my 4 and my x. I'll get 4x and my negative 4 and my positive 4 and get negative 16. You'll notice that right here, I have terms that I can combine, but a negative 4 and a positive 4, they cancel out. So all I'm left with is x squared minus 16. This is called the difference of two squares. Because the difference, right, subtraction, and both of these are perfect squares. So let's jump into how we would factor these. Let's say that I had x squared minus 64. Okay, so the big thing to pay attention to, pen is not working, both are perfect squares. All right, and separated by a different sign or subtraction sign. All right, so both of them are perfect squares and separated by a subtraction sign. So if you see a problem that looks like that, then you know, oh gosh, that's the difference of two squares. So what you're going to do, step one, is you're going to take the square root of both of those. All right, so take square root of each term. All right, take square root of each term. So I'm going to take the square root of x squared, which is going to give me x, and I'm going to take the square root of 64, which is going to give me 8. All right, so now I have the squares of each of them, right? So step two, put them in parentheses, one as a positive and the other as a negative. So put in parentheses one as a positive and one as a negative. Okay, so I'm going to do x plus, this will be my positive version, 8, and x minus 8. That will be my other version. And then congratulations, you have factored the difference of two squares. Well, of course, I want to go ahead and do another example. So let's say that I have, here's my second example. I have x squared and minus 81y squared. Well, don't panic because there's different variables. You're still going to do the same thing. You see that x is a perfect square, right? X times x, and 81 is a perfect square, and y is a perfect square. So you're just going to take the square root. So the square root of x squared will be x, and the square root of 81y squared is going to be 9y. Same thing, you could just go ahead and do x minus 9y for your first parenthesis, or you could do x plus 9y for your first parentheses, and then x plus 9y. So one of it being a negative and one of it being a positive. That is difference of two squares. So now we are going to talk about perfect square trinomials. Okay, well, perfect square trinomials, they can come in one of two ways. You might have seen how we have a plus b and we square it. Well, if you were to actually square those and multiply them out, a plus b times a plus b, you would get a squared plus 2ab minus b, plus b squared. All right, or, so here's one of them. The other one, if you were to do a minus b squared, which would look like a minus b times a minus b, you're just replicating the same problem, you would end up with a squared minus 2ab plus b squared. So let's talk about how to do this when we're actually presented with a problem, because this probably all sounds really confusing to you. So let's go ahead and say we have the problem x squared plus 14x plus 49. Okay, first thing you want to check are the first and last terms perfect squares. Well, x squared and 49 are. So what you're going to want to do is you're going to want to take the square root of the a and the b term. So step one, oops, spelling step wrong. Step one, take square root. You can always just factor it the way we've been doing, but if you can identify a perfect square trinomial, you'll just be able to do it pretty darn instantly. So take square root of first and last term. Okay, so I'm going to go ahead and take the square root of x squared, which will give me x. And I'm going to go ahead and take the square root of 49, which will give me 7. So now what you want to do, step number 2, check the middle term. Multiply your square roots. Multiply x and 7 together and times them by 2. So I would do 7 times x, and I would get 7x. Then I would take that answer, 7x, and I would multiply it by 2, and I would get 14x. And if you notice, this term, 14x, and this term match. So now what I need to do is, because it's a perfect square trinomial, you could write out the factors, just like we did x and 7 with a difference of 2 squares, one positive, one negative. Since these are both positive, you would do x plus 7 in parentheses and x plus 7 in parentheses, and that would be your factor. But the better way to write it would be x plus 7 in parentheses and then squared. So a recap. Perfect square trinomial. You look and see, oh gosh, are those first and last terms perfect squares? They sure are. That's a perfect square. That's a perfect square. Okay, I'll take the square root. I get an x and a 7, right? And if I want to double check, I can multiply these together, 7 times x, and times them by 2. And if this term and that term match, then you know you've done it right. Okay, so they're not always that easy. I have 2 more examples I want to do, and then we will call it a day on this video, which is turning into a rather lengthy one. I apologize. So I have 25x squared plus 60x plus 36. All right, well, I'm going to do what I did before. I see that 25x squared and 36 are both perfect squares. So I'm going to take the square root of 25x squared, and I'm going to end up with 5x. And I'm going to take the square root of 36, and I'm going to end up with 6. So now I can test this and do 5 times 5x times 6 and get 30x. And then I can do 30x times 2, and I end up with that correct middle term, 60x. So now I know my factors are 5x and a positive 6. And then squared, right? 5x plus 6 squared. And then the next one, number 3, gets a little bit trickier because we have a negative sign this time. So right here, we're going to have 4y squared minus 36y plus 81. All right, well, we're still going to take the perfect squares. Okay, so we're going to do the square root of 4y squared, which is going to give me 2y, and I'm going to take the square root of 81. So square root of 81, which is going to give me 9. Okay, so what I want to think about is, shoot, some way or another, I'm going to need to get a negative 36. So I'm going to go ahead and make my constant term, this 9, this will be my negative term. All right, so, and now I'm going to check it. I'm going to do 2y times a negative 9, which is going to give me negative 18y. And now I'm going to take that negative 18y, and I'm going to multiply it by 2, and I will get that negative 36y that I wanted up there. So, and also, if I square this, 2y squared, or 2y, square it, I do get 4y squared, and negative 9 squared does give me a positive 81. So I know that these are my two factors, and that factored it would be 2y minus 9 in parentheses, and then squared. Again, like I said before, you can always just factor like we normally have, but if you can recognize difference of two squares and perfect square trinomials, then you have to just take the square root and the sign in the middle, and there you go. All right, guys. See you at office hours.